Hello learners, I am Priyanka Gupta, working as Assistant Professor in Department of Computer Science and Engineering, Data Science at Institute of Aeronautical Engineering, Hyderabad. So, in continuation to the data mining subject, my topic is today is data pre-processing second. We have already completed data pre-processing first part. So, the content we are going to complete today is data reduction, dimensionally reduction, PCA, principal data analysis, heuristic search, numerosity reduction, regression in nonlinear models, histogram analysis, sampling, clustering, data cube aggregation, and data compression. Data reduction strategy. What is data reduction? While starting the pre-processing process, we have to clean the data. We have to transform the data. We have to reduce the data, and these some methods we have to apply before pre-processing. So we have already covered data cleaning part, and now we are having data reduction. So what is data reduction? In this data reduction, we are going to reduce the dimensionality of the data. If there are 3D data, we are going to reduce that data into 2D data. So that we call as a data reduction. So for data reduction, we need to obtain a reduced representation of the data set that is much smaller, much smaller in the volume, but yet produces the same result. That is almost the same analytical results that produce. So why we are using data reduction? Why it is needed? Why it is we can't use that manually? We can't do it as manually? No, we can't do that on a huge data sets, because we are having huge data sets. We are having larger databases. So we need to reduce the data reduction of the data. So a database and data warehouse may store a terabyte of data. What I have said, huge data set and larger data set. So we are storing the terabytes of data in that. So complex data analysis may take a large time, long time to execute, to run the complete data set. So for that we are having data reduction technique. There are some methods to reduce that type of data, very simple way. So we will get into the data reduction. What is reduction strategy of the data reduction? So there are some methods that is dimensionality reduction. First is dimensionally reduction, second is numerosity reduction, and third is data compression. And some other also is data cube aggregation. So we will get into one by one. What is dimensionally reduction? Dimensionality reduction is nothing but we have to reduce the dimension of the data. We have to reduce the dimension of the data. As I have said, as example, 3D to 2D. So what we have some methods for that. We have wavelet transform for that. The wavelet transfer method for that. We are having principal component analysis for that. That is another method to reduce the dimensionality reduction. Third method is feature subset selection and feature creation. So that is also a method to reduce the dimensionality of the data. Another method is numerosity reduction. So that is simply called as data reduction. That directly we call as data reduction, but some call as numerosity reduction. So there are some methods like regression and non-linear models that comes under the numerosity reduction. Histogram, clustering and sampling method for numerosity reduction. Data cube aggregation for the data numerosity reduction. Some method is data compression. That is another method for the dimensionality reduction. That is another method for the data reduction. Let's get started. Data reduction, dimensionality reduction. So what is this? When we are going to use curse of the dimensionality. When dimensionality increases, data becomes increasingly sparse. When the dimension of the data increase, obviously the data will become sparse. So then will be the curse of the dimensionality. We can reduce that type of data that is very heavy in the dimension. So we need to reduce in some small dimension. So then density and distance between the points, which is critical, like to cluster and outer analysis, and that after that only that become the more meaningful. Density and distance between points, we have to calculate that is more critical for the clustering, outlier analysis, and that after that is becoming meaningful. So that is another way to reduce the dimensionality of the data. So the possible combination of the subspecies that will grow exponentially, that is exponentially, that will grow exponentially. So the combination of that subspecies that always grow exponentially, that is dependent on that. So the second is dimensionality reduction. So what is that? Why it is causing? Why it is having? So that we avoid the curse of dimensionality, we are having dimensionality reduction. We have to help eliminate the irrespective features, like some of the features that is irrespective of the data, we need to exclude that data, and then only we have to use that data. So that also dimensionality reduction also has to remove that type of features very accurately, and then we can use that data as a good data, as a form of the good data. And after that we will reduce the noise also. In this dimensional reduction, we can also reduce the noise of the data. Noisy data we can remove from that. Reduce the time and space required in the data mining. That also reducing the time. Obviously, time is more important. So, by the use of data reduction methods, that is also causing to less time and less spaces, less time and less space. So for that, in that the data mining is required. That is also allowing the easier visualization. So after reducing all the dimensionality, obviously the visual presentation of the data will be more good and easier to see by the end users. While the dimensionality we will reduce, the data will be more easier to visualize. Next method is dimensionality reduction technique. So what is this? In this we are having some methods: wavelet transformation, principal component analysis, and supervised and non-linear techniques for feature elimination, feature selection and elimination. So these were the some examples of data reduction method for dimensionality reduction. So principal component analysis, that is called also as PCA. So if you are having some type of data, what we need to do, we need to find a projection. And that also captures the larger amount of the variation in data. We need to capture that. This is the sum graph. After the PCA analysis, we have found. So what we can see here, these are the some data points. These are the some data points on the regression line, that is more projected together. So we have to find the projection that captures the largest amount of variation in data. So there is also the variation. The distance is more, the more variation comes. The more distance is here, the more variation comes. So we have to find that. Then the original data are required to project onto a much smaller space, that can be resulted in the dimensionality reduction. The larger data set we need to project on a smaller space. That is, for that what we have to do, we have to find the eigenvectors. We need to find the eigenvectors. We need to find the eigenvectors that is in the linear algebra. The some method is there. So we have to find the eigenvector of the covariance matrix. We have to find the covariance matrix first, and after that we will apply the eigenvector to find the eigenvector. After that, what we will do, the eigenvector that define the new space, the new smaller space to project the larger amount of data at a one place. So that will be the dimensionality reduction. That will be the dimensionality reduction at a one place. So by this method, we can reduce the dimensionality very easily. So these were the numerical method to find the eigenvectors. So we will check step by step what we need to do while we are doing principal component analysis. So first, what we will do given n data vectors from the n dimension. If we are having n dimension data set, so we have to find the k that is less than or equal to n, the orthogonal vectors, that is principal component. To find the principal component, we need to check the orthogonal vectors from that data, and that can be best used to represent the data. That we have to normalize that. So we will do normalize that type of input. We will normalize that input data. So in that, each attribute fall within the some range. Obviously, the attribute that will comes under the some range. After that, we have to compute k orthogonal vector to find the principal component. We need to find the principal component. That is nothing but we have to reduce the dimension. So we will get one dimension apart from the. For example, if we are going to do 2 dimension to 2D 3D to 2D dimension, we can have some smaller components for that. We can have the reduced principal component for that. After that, we have to input that vector or data is because that is a linear combination of the k principal component vector. So as we know, that is a k principal component vector. So the principal component that are stored in order to decrease significance are its strength. Since the components are sorted, and the size of the data can be reduced by eliminating the weak component, we have to also reduce the weak component from the principal component that is related to that. So we need to eliminate the weak component, that is those with low variance. What are the component are low variance? Using the strong principal component, using the strongest principal component. So we have to remove that type of low variance component, and that is possible to restrict the good approximation to the original data. So that works for the numeric data only. So the method principal component analysis that only will be used for numeric type of data. numeric type of data. So these were the steps we have to do for the principal dimensionality analysis. Principal component dimensionality analysis. So second method is attribute subset selection. So in that is the another way to reduce the dimensionality of the data. So in that, what we will check? We will check redundant attributes. We need to check redundant attributes that duplicate much of all the information that contain one or more other attributes. We need to check that. For example, if we have to purchase the price of the product and the amount of the sales, the same amount of the sales tax paid, that is same, both of the fields are same, then we need to dimensionally reduce the one of the component. So, for example, we need to find dimensionally reduce in a one field. So, other is irrelevant attributes contain no information about anything that is useful for the data mining task at hand. We also need to remove that type of attributes from that. For example, if a student's ID is often irrelevant to the task for predicting the student GPA. If we are going to calculate the GPA percentage of the gross percentage of the marks of the students, then we don't need to identify the student ID number. So that is irrelevant type of attribute. We need to reduce that. So we have to select the subset of that attributes. Another example is, another method is heuristic search in attribute selection. So that is a method for attribute selection, that is heuristic search. So there are second possible attribute combination of D attributes. There are 2D possible attribute combination of D attribute. So there is another example. There is another method for attribute selection, that is heuristic search. In that, what we need to do? There are 2D possible attribute combination of D attributes. So that is typical heuristic attribute selection method. Some of heuristic attribute selection method are typical. They are best single attribute under the attribute independence assumption. In that, we need to choose by significance test. First, we need to do significance test. Then after, we need to make assumption for the selection of the attribute. So next is best stepwise feature selection. We need to feature select for the data set. So the best single attribute is picked first. The next best attribute condition is to the first. So the stepwise attribute elimination, that we eliminate the worst attribute. So in that, we have to eliminate the worst attribute by the repeat process. So another is best combined attribute selection and elimination. So we have to combine best attribute and to select that and eliminate that. So in that, optimal branch and bound, that is the method we can have optimal branch and bound to use the attribute elimination and backtracking. So after that, we will use the backtracking of the attribute to eliminate the not useful attributes. So that is branch and bound optimization of the attributes. Data numerosity reduction. So that is another method for the data reduction. Data dimensionality reduction. So what we will do? Reduce data volume by choosing alternative. We have to reduce the repeated data volume by the alternative and a smaller form of data presentation. a smaller form of data representation. So the method is parametric method and non-parametric method. So in parametric method, that is also the call as regression method, and non-parametric method, that is another things, histogram, clustering and sampling methods. That are all the models that is non-parametric. So in parametric methods, we can have regression model. So we have to assume the data that fits into the some model. After that, we have to estimate the data model parameters. Data model parameters. After that, we have to store the parameters. After that, we have to store that parameters, and then we have to discard that data in a possible outlier. If we are having the outlier, we have to accept that. We have to choose the accept outlier data from all the data. That, for example, log linear methods that obtain the value at the point in MD space as the product on appropriate marginal subspaces. So that was the example for parametric method. Non-parametric method, these are histogram, clustering, sampling. So in that, we don't assume any models. We don't have to assume any models. We just apply the histogram, clustering and sampling methods to numerosity reduction of the data. So parametric data reduction, regression and log linear methods. What are these? These are the linear regression, multiple parametric data reduction, regression and log linear models. First one is linear regression models. So in data, a model to fit a straight line. If the data is, we have to fit the data in a straight line, so that that comes under the linear regression of the data. That is often uses the least square method to fit the line. These are also the least square method, LSE, that is the mathematical formula to calculate the regression from the data. So we need to calculate the regression from that to find the fit line from the as a straight line. So there is also second method, that is multiple regression. In that, we have to allow a response variable y to be modeled as a linear function of multidimensional feature vector. What is multidimensional feature vector? That is whose dimension is more than 1. That is a vector. So for this, we have to model a linear function. So in that, we need to regress that model. Another model is log linear model. So that approximate the discrete mathematical multidimensional probability distribution. To find the probability distribution for multidimensional, we need to apply the log linear model for discrete type of data. So these were some examples to regression and log linear models. Regression analysis. What is regression? Regression analysis is nothing but a collective name of the technique for the modeling and analysis of numeric type of data that consisting of values of dependent variables, also called the response variable, a measurement, and of one of more independent variable, that is also called explanatory variable, or predictors. So what is this? Here in graph we can see x and y axis. In y axis there are something projected, that is called as y is equal to x plus 1 to find the regression line. That is the regression line. So here x1, y1 dash and y1, this thing. So this is y is equal to x plus 1. So this field is called as a dependent variable, that is called a independent variable. That is called a independent variable. So we need to find that from the regression model. So the parameters are estimated so as to give the base fit line of the data. Base fit line of the data. That is most commonly the base fit is evaluated by using the least square method. Least square method. So there are some mathematical formula to calculate that type of base fit line, but the other criteria have also been used. That is also used for prediction, prediction and modeling of causal relationships. Income under including forecasting of time series data. If we are having some time series data, for example, if we are having some time series data, we need to predict some forecasting. We need to have some forecasting. So we will use the regression for that. This also used for that prediction. Regression analysis and log linear models. So linear regression, y is equal to wx plus b. Two regression out coefficient w and b is specified the line and are to be estimated by using the data at hand. Using the least square as criteria to the known value of y1, y2 to x1, x2. y1, y2 to x1, x2. Multiple regression. Multiple regression formula is y is equal to b0 plus b1, x1 plus b2, x2. These are the multiple factors for the as a coefficients. So many non-linear functions can be computed or transformed into the above that has been predicted. What are the log linear models? Approximate discrete multidimensional probability distribution and also estimate the probability of each point and value tuple in the multidimensional space for a set of discretized attribute that is based on a smaller subset of dimensionality combination. That is also useful for dimensionality reduction and data smoothing. The log linear method is used for linear data modeling, data smoothing and dimensionality reduction. So the non-parametric model are histogram analysis. So in histogram analysis, what we will do? We will divide the data into buckets and store some average, a mean. We can say sum. Here we are calling at sum for each bucket. This is the bucket. For one data, there is a bucket. For one data, there is a bucket. We can have a graph that is showing the values here. That is a histogram of some data. So we are having 10,000, 20,000, 30,000 to 1 lakh. Here we are having 0, 5, 10, 6, 15, 20, 25, 30, 36, 40. These are the values we are having. So in between 10,000 and 20,000, they are having some graphs. They are having some bar graphs. So the space between that is called as a bucket. So we have to divide data into buckets and store that average for each bucket. We have to store that into one bucket. After that, some partitioning rules we apply. So equal width. For that equal bucket, we have to range. We have to range the equal bucket for that. And another is equal frequency. Or we have to equal depth. Equal depth we need to. This is depth. This is width. This is depth. This is width. So by this we need to partition that buckets for the one bucket. So that is the step to do. Another example of non-parametric, that is clustering. Clustering is nothing but partition data set into the clusters that is based on similarity and the store cluster representation. That is nothing but centroid and diameter only. So that is the cluster representation. So that can be very, very effective if the data is clustered, but not if data is smeared. What is this? It is when our data is cluster, data is stored as cluster, then it will be very, very effective. Otherwise, it will be not effective. So we can have some hierarchical clustering and be stored in multi-dimensional index tree structure. There are many choices of clustering definition and clustering algorithm. Clustering definition and clustering algorithm. Cluster analysis will be studied in the next examples. So, sampling. Types of sampling. There are also non-parametric method that is called as sampling. So, first we will get into the types of sampling. So, first is simple random sampling. So, there is an equal probability of selecting any particular item. If there is a probability to select any particular item, so equal probability, we will use the random sampling. Second is sampling without replacement. So once an object is selected, then it is removed from the population. If we will have some object selected, we will remove from there. And we will use that as a sampling. We don't have to replace that data. Another is sampling with the replacement. That was without replacement. That is with replacement. So in that, a selected object is not removed from the population. Same thing in this, we don't need to remove the object from the population. Stratified sampling. What is that? Partition the data set, draw the samples from each partition, that is proportionally approximately the same percentage of the data. So there will have some same percentage of data, that only we will partition the data set and then used in conjunction with skewed data. That is used in the conjunction with skewed data, only then we will use stratified sampling. That was the example of sampling. That was the type of sampling. So in this graph, sampling with or without replacement, that is two examples of that. There we are having some raw data. In that is the simple random sampling without replacement. We don't need to replace the object. Here in that with replacement, we need to replace that with another object. So by this we only need to take the sampling. What is actually sampling? The sampling we are taking from any population as a example. The some part of the population we are taking as an example, that will be true for the all population. That is called sampling. So there were some types we have seen. So some of the type we have seen, and that is some example of that, real-time example of that, how we are doing the sampling without replacement and with replacement. So what is sampling actually? I'll tell. Sampling, obtaining a small sample from S to represent the whole data set N. Whole data set N we can call as population. And we will have some sample S from that we will call as sample. So a small sample will take from the population, that is called as a sampling. That method called is sampling. Allow a mining algorithm to run in complexity that is potentially sublinear to the size of the data. What is the key principle behind that? We have to choose a representative subset of the data. So first we need to simple random sampling that may have very poor performance in the presence of skewed data. Then we have to develop adaptive sampling method, that is stratified sampling methods. So we have seen this example, this type of sampling in earlier slides. After that, sampling may not be reduced database inputs that pays at a time, that don't reduce the database inputs. So this is the example of the data, that is a graph that is showing cluster and stratified sampling. That is a simple sampling, cluster sampling. These are the some data points. These are some data points. These are some data points from the data set, and these are the clusters. These are separating some types of data items, some form of data items separately. That is called as a cluster. So these are the cluster. So this is called as a cluster sampling. In that cluster stratified sampling, these are the stratified sampling. So we can have some strata for the cluster. So this was the example of the simple cluster analysis, cluster sampling and stratified sampling. Data cube aggregation, that is another method for the data reduction. So the lowest level of the data cube, that is base cuboid. What is data cube? What is data cube? So I'll tell you. In data warehouse, we are storing a large amount of data. That to fetch that type of data, there is a process ETL. There is a process ETL, and the data we have to use that type of data in. We have to see that data in a data cube. So the lowest level of the data cube, that is the aggregate data for any individual entity of interest. For example, a customer in a phone calling data warehouses. A customer in a phone calling data warehouse. So that is an example of the data cube. Multiple levels of aggregation in data cubes. So the further reduce the size of the data to deal with. That also reduces the data size of the data. Reference appropriate levels. So use the smallest representation which is enough to solve the task. That is the smallest representation level that is going to solve the task. Another thing is queries regarding aggregated information should be answered using data cubes. Data cubes only will be answered with the data cubes when we want. When we need to do that, then only that query regarding aggregated information will be answered. So now another method called data compression comes. So data compression. What is data compression? Some type of data we have to compress into lower level. So string compression. There are extensive theories and well-tuned algorithm for string compression. Typical lossless but only limited manipulation is possible without expansion for the string compression. There is audio video compression. So typically lossy compression with progressive refinement. Sometimes the small fragments of the signal can be reconstructed without reconstructing the whole process. So for the audio video compression that we are doing. Time sequence is not audio. There have some example if we are having some time sequences, so that will be not the example of the audio sequence, audio compression. So typically short and very slowly with time, that type of time sequences we will not use for the data reduction. Dimensionality and numerosity reduction may also be considered as the form of data compression. So this formula is for this type of reduction we also can have for data dimensionality and numerosity reduction. So this is the example for data compression. So this is the original data. That is the original data that has been compressed. That is lossless. That is also lossless. And thus, if there is lossy data that has been approximated as original data, that is the data compression. So after the compression, the original data which is approximated with the lossy data, that is called the original data approximated after the data compression method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.